Hello, everyone. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Concord, New York, and there is my email address. Excuse me, my voice is going on me. We're going to be talking about today's piecewise functions. So this is a graph of a piecewise function. For every x, there's only one y. Okay, that's true because of these open circles. Okay, there's nothing that is right above each other. So good. That's a piecewise function. For every x, there's only one y. It's a function, I should say. It's a piecewise function because it changes direction. Okay, now, the important thing to remember about piecewise functions when they're written as equations or inequalities are these parts right here. That defines the domain for specific parts. So this part here defines the domain for each part of the function. Okay, so when I look at this function right down here, here I am looking at it, and it says, this is function notation. Evaluate the function at -3. Is -3 between 3 and 5? No. Is -3 between 1 and 3? No. Is -3 between -3 and 1? Well, it isn't, but that has an equal to there. Is -3 less than or equal to -3? Yes. So I have to grab this equation. So we just looked at each section to find the domain, that makes the stuff inside the parentheses true. Okay. Use that equation to answer the question. So I write down -2, absolute value, -3 plus 1, absolute value, equals. So I took this and filled it in. This is -2 times the absolute value of -2. You could do that on the calculator, and the answer is -4. Okay, you know where the absolute values are. It's second zero. Okay, now let's do one more together, at least one more together. I look at the stuff that makes 0 true. Is 0 between 3 and 5? No. Is 0 between 1 and 3? No. Is 0 between -3 and 1? Yes, it is. So I use that same one again. -2, absolute value, 0 plus 1, absolute value, equals -2, because that's -2 times 1. Okay, this next one throws a little twist. Look for the 2. Let me see. Is 2 between 3 and 5? No. Is 2 between 1 and 3? Yes. So I'm going to use that equation. What? Yeah, use that equation. -4. Is there any x's? No. So I can't plug the 2 in anywhere. That's it. For anything between 1 and 3, all you do is say -4. Kind of like your 2-year-old brother or sister. Can you help me? No. Do you love me? No. Do you want to play with the dog? No. Whatever you say, the answer is always no. So whatever you say here, the answer is always -4. Now it says graph the piecewise function on the graph paper below. Okay, so when I graph something that is piecewise, I'm still only going to pay attention to these. I go from -3 to 1, 1 to 3, good, 3 to 5, okay, it's continuous there. So I'm going to go from -3 to +5, -1, 2, 3. Not going to go anything on that side. So I'm going to start at -3. I'm going to plug in -3 into the equation. -2 times -3 plus 1 equals -4. Now I'm going to plug the endpoint 1 into the equation. -2 times -3, it's supposed to be a 1, plugging it in, so 1 plus 1 equals -4. Okay, now there's something funny going on here. This is not a line, it's an absolute value symbol. So I typed that into my graphing calculator, and I got a table. -3 is -4. -2 is -2. -1 is 0. 1 is -4. There we go. So there's the table, and we plot those points. I'm going to hit pause while I plot them. Okay, so I plotted the points. Now I'm going to take a closer look at the question, and it said to fill in both ends because it's underlined. Okay, so I made closed circles on them. There. Now, I know it might be a little confusing. Don't worry, we're just going to take this one little step at a time. Now, this is easy. It's -4 all the way from 1 to 3. So we go to -4 from 1 to 3. -1, -2, -3, -4 is already a point there. To 1, to 2, to 3, and 3 says it has to be open. Why does it have to be open? Because it doesn't say equal to there. It says just less than. Now, we're going to do this equation from 3 to 5. So I'm going to make a table from 3, 4, and 5. And I'm going to take a look at my graphing calculator. I'm going to plug that equation into my graphing calculator and look at the table. Now I have to just look at the table from 3 to 5. It says, with this equation, just look at the table from 3 to 5. So that's why 3 is -4, 4 is -6, and 5 is -8. Don't look at any other part of the table. So when I go to 3, 1, 2, 3, tells me to go to -4. 1, 2, 3, 4. This one happens to be right on top of the old spot. And it says to fill it in because it's underlined. And then plot the other 2 points. 4, -6, and 5, -8. There they are. And connect them. That is a piecewise function. Okay? Looks like someone dropped a mirror on the floor or something. That's why it's called piecewise. We learned that when we want to evaluate the function, we take a look at the number inside. Which part is it supposed to be at? Okay, got it. And then plug it into that equation. When we want to graph it, we graph each of these separately, looking at the tables, making tables only from -3 to 1, only from 1 to 3, and only from 3 to 5. And we graph those parts. Now on the next page is a problem just like it. Did I tell you what page we're on? Well, hopefully I will in the very beginning. So you can do page 311 with the people near you, and also finish up 310, what I didn't do with you. 312 is graphing, and so is 313. Remember, you're going to do the table. This one, the table is going to go all the way to -infinity. Okay, so you're going to do a table like -4, -3, -2, and -1. Then you're going to go from -1 to 4, and then you're going to go from 4, 5, and 6 and graph them. Okay? Okay, kids, that closes today's lesson. If you have any questions, make sure you ask. Excuse me, my voice is really going. Catch you later. This is Mr. Bryce. Bye-bye.